Well, today we're going to talk a little bit about some basic engine repair stuff. Some of you guys seem to enjoy that. I got quite a few slides here, so I'm going to jump into this thing post haste. And just about everybody that's done an engine overhaul knows how many parts there are. But when you see them all laid out like this, it looks pretty amazing. This was an LS engine, and look at all that just stuff. If you lay out every last little part, there's quite a lot of stuff there. You know, you got your heads in your spark plug, and you got your block, and you got, in other words, excuse me, that right there's your valve covers. Your head's over here, ha, dummy. And so anyway, look at all that stuff. Connecting rods, pistons, crankshaft, all that stuff's laid out. It's got to be put together. When you put an engine together, you're supposed to periodically turn it, you know, to make sure that it doesn't get too tight. They even do that at the assembly plant. Whenever they build engines, or they did at the assembly plant, the plants that I have visited where they build engines. But there's all these configurations, and then, you know, we could go on for a while about that. You know, whenever you're talking about companion cylinders, it's a little harder to pick out the companion cylinders on something like a 3-cylinder or a 5-cylinder. But on a 5-cylinder, the cylinder that's usually by itself is cylinder number 3 because it's right in the middle. But anyway, that's another story, and we'll talk about it another time. This right here is an old VW Bug long block, and you know, this, you can see this I6 looks like a Trailblazer or something like that. Rotary engines I worked on whenever I was at the Mazda dealer in the early 80s, and those were interesting, particularly the ones with distributors. You can put the distributor in 180 out on a rotary engine, and it will still run. It'll just idle rough. Which I've found that out the hard way. You know, it's not like a regular piston engine. These right here, I've rebuilt these old tough slant 6 Chrysler engines, and so on and so forth. But you get the point here. There's blocks. This is a block, long blocks and short blocks. Now, this one guy was asking this question: can you tell me if my wife's van has a long block or a short block in it? And the truck mechanic looked at me and said, I'm going to let you answer this one, and he walked off. Because bless his heart, the guy he didn't have a clue what they were talking about. He had gone into the parts room. He said, I need to get an order, see about ordering an engine for my wife's Aerostar. And they said, you want a long block or a short block? And he said, well, I don't know which one of those it has. And so he came out and he asked us about that. But it was funny. Bore and stroke. If you've never used one of these, it's annoying to set the thing up, but once you get it set up, it's super easy to check tapering out around with it. I taught my students how to use one of these, but you have to have a big mic. It's like a 4-inch mic or whatever to set it up to begin with. Then you got to zero it, and then when you put it down in the cylinder, this little spring-loaded part down here enables you to just work that thing in there. There's other ways of measuring, you know, with inside mics and stuff like that. But this right here is probably the easiest and the most accurate. Once you get it set up, it's really easy to use. And so the stroke bore measurement is here. The stroke measurement is here. So how far it is from here to here on these journal centers is a stroke measurement. I rebuilt that 47 Willis Jeep one time, and it had a seriously under square engine with long rods and little skinny pistons and all that. But that's one of the reasons the thing had so much power, because you've got more torque with an under square engine than you do with an over. If you've got an over square engine, it'll rev really fast, but it doesn't have as much torque because the crank's not as long, right? But if you've got you got a square engine, which is kind of like a 350 Chevy, is real close to being a square engine. Then it's sort of, you know, you got the best of both worlds. And if you got a under square engine, it doesn't rev all that fast, and it's harder for it to rev as high, but it has more torque. The bore's got to be perfectly round and not tapered. The piston skirt causes piston slap. This is where on the skirt that I've illustrated, this would be one that's just right. This is taper. I illustrated there, cylinder taper, which usually happens at the top of the cylinder. But one of the things that just boggles my mind is how many times we threw rings and bearings in engines, and, you know, like rod bearings and piston rings. You know, of course, you know, new gaskets and all that, and maybe a timing chain, and we would consider ourselves having rebuilt the engine, and it would run for a long time. But really, the right way to do it, if you've got a high mileage older V engine, is to bore the thing out 30 thousandths, get you some new pistons, some good ones, and start over, brand new. You can bore it, if you bore it much more than 30, you're going to have some issues. But 30 is what you're going to is the comfortable place to bore it. When you bore at 30, you've taken care of all the taper and all the out around typically, and then occasionally, if you bore it, if you bore at 60, you may get into the water jacket and have to put a sleeve in there or something like that. But one way or another, these are the things you need to consider. And I'll talk a little bit more about the rings here in a minute. Crankshaft, the stroke's determined by the crankshaft, not the length of the connecting rod. If you change the length of the connecting rod, you're just moving the piston up or down, but the stroke remains the same, see? And so, in other words, you're moving the stroke of the piston is, the travel of the piston is changed, but the stroke is not. So if you've got a longer connecting rod, it'll go closer to the head, but if you've got a shorter connecting, it won't go as far down, see? So anyway, I could talk about that for a while too. This right here was a 4.2 liter Ford that we worked on, and the story on that was the guy had it at 2 or 3 shops, and well, 2 of them had rebuilt it, but it kept having oil pressure issues after 3,000 or 4,000 miles. And so he brought it to us, and because the other 2 shops just blew him off. They wouldn't even look at it again after it, first one rebuilt it for $1,700. 3 months later, he had oil pressure issues. No, I say 3 months, 3,000 or 4,000 miles later, he developed oil pressure issues. Or maybe 7 or 8, I don't remember what it was, but it was, the oil pressure kept going away. So he went to a second shop because the first shop said, no, we're not going to work on that anymore. I don't know why. The second shop said, oh, they didn't do this right, and so they charged him another $1,600 to rebuild the engine again, and 6,000 or 8,000 miles or however far it was, he lost oil pressure again. And so he brought it over there. We got a crankshaft kit, bought it from the parts store, and we replaced the oil pump, and we replaced the cam bearings, we replaced everything that we thought might possibly, be the cause of an oil pressure issue. He drives it 4,000 miles, the crankshaft breaks, pop. Well, the parts store wouldn't. The parts store said the crankshaft, people that sold a crank kit said they wouldn't guarantee it because they didn't guarantee 4.2 liter crankshafts. And so he gave us another crank kit at his expense because he didn't know the first one he sold us wasn't guaranteed. But the problem with that was you could take a straight edge and a feeler gauge and measure that block with all everything out of it, and it looked like it was okay. But when you put that crank in there and you started torquing it down, it would lock up and wouldn't move. So I had to take the block and get it line bored so that the crankshaft would spin freely. Anyway, after that, the guy drove the truck a long way and never had any more oil pressure issues with it. Pistons and rings, the wrist pin, connecting rod, bearing, everybody knows about this if you've done any engine work. The graphite coating that you see on a lot of these pistons is to keep that skirt from wearing out so quick. A lot of times when you pull it out, that coating is worn off, but the aluminum has been preserved. Measure ring gap. One of my students was going to rebuild his engine in his little V6 Camaro, and we got all the parts. It was going like $1,200 worth of parts he got, and I says, and he was getting ready to put the rings on the pistons. I says, don't do that before you put the rings in the cylinders. And of course we honed the cylinders out to break the glaze and all that stuff. But I says, he measured the ring gap. There was no ring gap at all on those new rings. And so what we had to do was take and file the rings so that he'd have some ring gap. Now, if you put it together without checking the ring gap and you've got no ring gap and you manage to get the pistons in there, this thing will run about 10 minutes, and whenever the rings start to heat up, they'll swell up and the engine will quit. And then after it cools off, it'll start again, and it'll run another 10 minutes, and then it'll hunker down and quit. So measuring that ring gap, and that was something I never did when I was growing up, when I was in my, teens and 20s building engines and stuff. I never measured a ring end gap. But it just so happened that I was cautious enough to have this kid measure a ring gap, and he found that he didn't have any, and after that, when he got the engine built, it ran just fine. But it will run a little bit and swell up and quit if you don't have any ring gap at all when you get your new rings and all. And a little bit of product variability is all it takes to do that, even if you've got, you know. Anyway, let me move on here. But let me ask you this: what's wrong with this picture? These ring gaps should never be stacked like this. If they are, you're going to have compression loss there. So what you're supposed to do is you're supposed to put these gaps on these rings on opposite sides of the piston. That's the right way. And there's your oil ring, expander ring, and all that kind of stuff. Newer engines have low tension piston rings. Older engines had higher tension piston rings. I mentioned this, I think last time I had a video, is if you, with the high tension piston rings, if the cylinder walls go dry when one's been sitting for a long time, it'll spin really slowly until the cylinder walls get oiled again. High tension piston rings, if the cylinder walls are washed down, then it'll just spin like it ain't got no compression, you know. Plastic gauge for bearing clearance is all important. There's nothing you can do that will make give you as accurate a measurement on actual bearing clearance. More than 1.5 thousandths is too much typically. You know, of course, it's a little waxy string, and you put it in there, and you torque it down, you take it back up, and then you use that little gauge on the side to see how much clearance you got. One time there was at the Ford place, I was working on a Chevy Citation. I don't know why we were doing that. I always wondered why somebody would bring something like a Cadillac or a Oldsmobile or a Chevy to the Ford place to get it worked on. It was wacky. But what I was commissioned to do by the shop foreman was to replace the crankshaft without pulling the engine out of the car. Now I had to pull the transmission, had to get the flywheel off of it and all that, and I had to pull obviously the belts and the balancer and all that kind of stuff, and unbolt all the rods, pull the crank out of there. You know, this was a crankshaft kit we were putting in there, so we put all the bearings that came with it back up in there. I don't know if anybody's ever done that before, but it was no fun. Anyway, put it all back together, buckled everything down, and we cranked it up. And after a little while, I noticed that the oil pressure was low, lower than it should have been. So we went back in there and plastic gauged the bearings, and we had like 2.5 or 3 thousandths of clearance. And so what we did was we sent the thing to these crazy ideas that some of these people have that's calling it shots. I was just basically a soldier getting orders. But they said, well, we're going to pull the crankshaft. They're going to turn it 9 thousandths and give us some 20 thousandths over bearings. And they did that, and we measured the clearance before we ever buckled it up and started it back up, and it still had too much clearance. And so finally the shop foreman told me, this is an old car anyway, let's just foul the bearing caps a little bit. Which is what I did, and I got the clearance like it was supposed to be that way. That's a stupid way to do that, but it worked. You know, after a while you get in there so deep, you just got to figure out some kind of way to salvage this situation. But anyway, plastic gauge is terrific stuff. It doesn't cost much. That's the best part about it is it's so cheap, but it's also so accurate when you use it right. There you go, camshaft and valve train. Now, you know, sodium-filled valves. There's YouTube videos on there that I've seen of these guys grinding these sodium-filled valves open just to see how explosive that sodium is. And I'm telling you, that stuff it can literally kill you if you grind in there and, you know, manage to get some water in the center of a sodium-filled valve or something. It'll just explode. Look up some videos on that. Sodium-filled valves exploding, you know, whenever somebody grinds into them. That's scary as all get out. Holding that valve in your hand, you don't think it's anything but a piece of metal. But basically, they have the sodium in there because it melts at 97 degrees Celsius and it flows inside the stem to keep the valve cool. But that's usually, you're going to find that on turbocharged engines, and you'll find it on higher performance ones and all that kind of stuff. A lot of the time, most of them that aren't high performance are going to have just solid valves. But be aware of the fact that if you got sodium-filled valves, you do not need to put that thing on a grinder and grind it. You know, I mean, it's scary to think somebody might do that. And, you know, don't do this if you don't. I mean, I'm not going to tell you to do this at all. Do not do this. So don't come back and say, hey, you told me to do this. I did not tell you to do this. I told you not to do this. Sodium-filled valves are very, very dangerous if you grind into them. Single overhead cam became a thing long years ago. Now, what we don't often think about, and I'll mention that later, is that when you've got overhead camshafts, the oil passage, there has to be an oil passage going into the cylinder head that's pressurized instead of having just, you know, splash oil and all this or coming up through the push rods like they do on a lot of push rod engines. You've got to have a pressurized oil feed for these cam saddles. And here's something else that's strange that you might not have even known. You can buy replacement cam caps for certain engines. You look that up. You can find those on Amazon. And some, see, that because there's not any cam bearings in here, you typically just have these things clamping around the camshaft, and rather than having cam bearings in here on most engines. And so, you know, it's kind of like on those little one cylinder small engines. They don't have rod bearings. You know, the connecting rod just is the bearing. You know, and that's the kind of the way this is. And when these start to wear out and you start to lose some oil pressure there, you liable to have trouble because there's oil being pumped up to these you know, these saddles. But anyway, keep that in mind. You got to have pressurized oil going up there. On some of the Explorers, they'll have a little rail going across the top of here that's actually dripping oil or squirting oil on the cam lobes, and that's an interesting design and all that. But anyway, you get timing belt here, and these are timing chains. Timing chains will have colored links that you have to line up. The crazy thing about the colored links is, unlike the timing marks on your pulleys, they don't line up every time they go around. Those colored links are going to walk. So you got to turn those things a long way before them links walk back around and get on the marks on those pulleys. So you need to keep that in mind too. Dual overhead cam is you know, a bit more complicated. You got and you'll have timing belts with those too. A lot of them, like on some of the Ford Contours and stuff, you don't have. These are not keyed. You basically loosen these and you put the you position the camshafts. And whenever the camshafts are positioned, the crankshaft's positioned, sometimes you'll need special tools for that of various different descriptions. Once you get the camshaft and the crankshaft where they're supposed to be, then you lock the pulleys down. You know, particularly these two right here. Of course, you know, you got this one driving that one on your. A lot of you don't know if you hadn't worked on them very much. These 2.2 Toyota engines, the little timing belt ones, that's a dual overhead cam, but it's got gears on the inside of the valve cover where you can't see them, scissor gears, driving the other camshaft. So those two camshafts, those dual overhead camshafts, they only got one pulley on the outside that you can see, but it's got two camshafts under the valve cover. That's an interesting design too. And the camshaft, because they're geared together, spin in opposite directions. All that's going to be factored in. Driving the cams, you got belts, you got chains, you got variable cam timing, all kinds of stuff like that. In a lot of cases, if you're going to put a water pump on one, it's a good idea to go ahead and get the whole kit. It comes with a belt and these pulleys and this kind of thing. It's just, it'll come with one of these pulleys, and the water pump and the belt. And just go ahead and change all that stuff so you don't get the ugly surprise later on. These plastic timing chain guides will wear out and flop around and cause let the chain start slamming against the cover. And then you got, unless you've got at least 25 psi of engine oil pressure on, like for example on 3-valve Fords, you're going to have timing chain noise, and that's an annoying procedure there too. But timing chain noise happens if the oil pressure driven tensioner is not working right. Oil pumps come in a lot of flavors. You know, you got these gerotor pumps and you got vane pumps. This is a crescent gear pump, and of course you got these pumps right here. If you've ever taken an oil pump with the rod in it so you can spin it, I'm talking about one of these kind of like here, like you put on a you know, underneath in the pan. If you put that thing down in the oil, right, and you got it where when you spin it, it's going to pump oil. If you just spin that thing with your fingers one time, oil will shoot out of that thing and go halfway across the shop. I mean, it's just incredible how much oil this thing moves. Now, these are positive displacement pumps, but if you don't have an operational relief valve, if you got the relief valve stuck closed, it can blow the oil filter slam off. If the relief valve spring is broken or is stuck open, then you won't have any oil pressure. It'll destroy the engine. So that relief valve is all important when it comes to oil pumps. Sometimes it'll be built into the pump. Sometimes it'll be built into the cover that the pump's bolted to, and, you know, and that kind of thing. But that's really important. Alright, driving the oil pump here, you're going to be driving it at either at half crankshaft speed if it's driven by the distributor, or at full crankshaft speed if it's driven by the flats on the crankshaft. Um, or on these Toyota Camrys, it's driven by the timing belt. So on the 2.2 Camry. Some of the Cadillacs years ago had an issue where people would park the thing out there on a hot day and they'd get out and go in the store and they'd come back out and they'd crank it and it wouldn't have any oil pressure because the oil pump had lost its prime. And the Cadillac dealer, what they were told to do by Cadillac was to put 20 quarts of oil in the engine, start it up, and it would force that oil pump to get prime. And then they would drain it down to the number of quarts that were supposed to be in it. Believe it or not, that was a wacky, crazy thing they did to get it to get some get prime. And that's a dealership thing there. So just keep that in mind. It's I don't know if you ever heard that before. Oil gallery is an interesting thing. You know, you got your oil comes in here and it gets pumped out into this gallery up to these bearings and through the oil filter. The only component that receives unfiltered oil on an engine is the oil pump, and it basically has got a little coarse little screen down here in the oil pump pickup. But on the ones that had the timing chains with the camshafts in the block long years ago, if you had a timing chain, it was aluminum gear with plastic teeth on the outside of it, which basically they did that because the chain wouldn't stretch as bad because the gear wasn't as heavy, I guess, because back whenever I was buying a lot of timing chains and gears and stuff in the early 80s, the guy at the Delco parts supplier says the aluminum plastic gear is $23. The steel gear is $20 or $18 or something like that. He said if the aluminum plastic gear is more expensive than the steel gear, there's a reason that the OEM puts that on there. They don't spend more money unless they feel like they're going to get something out of it or it's going to save them something. But anyway, if that plastic starts shelling off those gears, it can go down in there and get small enough particles, get up in here and lock the oil pump up. And I've seen that. My brother's 71 Thunderbird did that. He's just driving along, all of a sudden it quit because it locked the oil pump up, and the oil pump was driven by the distributor by way of the camshaft. The distributor stopped turning, the engine quit, it busted the gears off the cam, and I had to pull the top of the engine off, the front of the engine off, and I had to put the camshaft in there. Speaking of camshafts, here's a funny little story. In '84, I was working at a Lincoln dealer over in the town up the road, and there was a car that came in there that had it was a Grand Marquis, I guess it was, the Mercury version of the LTD. And this thing was skipping on cylinder number 3 or some cylinder there, and the guys on the other side of the shop looked and worked at it and trying to figure out why it was skipping. Wasn't that complicated. You had throttle body injection. There wasn't a bunch of injectors to worry, so every one of the cylinders was getting the same amount of air and fuel and everything. And so the older guy over there that had all that experience, he said the only thing, and this is a brand new engine, he said the only reason I can come up with that this thing is misfiring on one cylinder and nothing else is wrong is that it's got a bad camshaft. So they said, okay, so they gave it to me to put a camshaft in it. And I thought, this is the craziest thing I've ever heard. Never heard of this in my life. But I went ahead and I ordered me a perfect circle camshaft from the parts house. Now remember, this is a new car that's never been sold or still on the lot in '84. And when I pulled that camshaft out of there and I laid it on the bench next to that perfect circle camshaft, I looked at both of them and I turned them through. I didn't use a micrometer or anything, but you could not see anything wrong with that camshaft that came in that car new. I put that perfect circle camshaft in there, buckle that thing up, and it ran perfect. And so that's the only time I've ever seen that, and you may never see it. And because of the fact that it was a brand new car, see, that was a defect from the factory. You're not likely to see that. Of course, you'll also see cam lobes wearing out, and you can actually, if it's a pushrod engine, you can take a dial indicator and you can set that thing up on the suspect cylinder. We've done that before too, and measure the valve lift and compare it, right on top of the pushrod. Set your dial indicator up, bar the engine over, and watch how much valve lift you got. Okay, that's important, and because it's it's directly sitting on the camshaft via the lifter. And we have on a 4.8 liter that wasn't misfiring, but it didn't run quite right, and I didn't really feel a lot wrong with it. Didn't expect a 4.8 to have all that much juice, but the guy that was driving it said it's lost some power. One of my students heard some noise under the valve cover, and he said, I think something's going on over here. And we found out that the camshaft was starting to round off on cylinder number 4, I think it was. And so we wound up just going ahead and dropping a block in there, you know, putting a used engine put in there. The truck belonged to the college, you know, so it wasn't a customer's vehicle, but we still popped an engine in it. And we upgraded it to a 5.3. The 4.8, the 5.3, and the 6.0 in those 200XX series, you know, like 2000s, that's a plug and play. You know, we just put him a 5.3 where the 4.8 was. We didn't have to reprogram or anything. Works real smooth. It was 1998 Chrysler 2.7. I got to find this cutaway of this online, and those things right here. Some of the mechanics that I was talking to when I was reading Motor Edge articles about these would just say they would start bawling and squalling when one of these came in. And these things got little, you know, lifters and roller rockers and all that kind of junk in them. Water pumps right here. The way this thing's fixed up, if the water pump leaks, the thermostat is down there in the side of the block. Between the, like if you look in there between the air conditioner compressor and the block, you're going to see the thermostat. Next to the thermostat, there's a hole. That's the weep hole. See, and Ford didn't do this when they put water pumps in there. They didn't do that. If a water pump on a Ford leaks, it fills the doggone crankcase up with coolant, which is stupid. But the Chrysler folks, in their infinite wisdom, they gave this water 2 places to go so it wouldn't go into the oil. One place was out here by the thermostat. There was a hole. If that stopped up, it would go in underneath the in the valley between the heads, and then there were some holes on the back, and it would drip out around the transmission. Of course, the only problem with that is that there's a plastic cover. I mean, it looks like a thermostat housing, but it's not, because the thermostat's down here. This thing with the bleeder on it, and I should have put a picture of it, it'll leak, and it'll cause a bunch of coolant to run out around the transmission and make you think it's got a bunch of bad freeze plugs or something. But be aware of that. Pumping coolant. We got all this water.
And that just spins around like it wants to. And that I expect would probably. That water pump is pretty well done all it's going to do, I think. What amazes me with that little
shaking like that, having to do with the water pump.
Grab a hold of that fan and start wiggling that water pump, you see it moving, and you got issues. I like to play with these things right here. If you take one of these water pumps that's got this pulley shaped on like this, you can tap that thing with a wrench and it sounds like a boxing ring bell. You know, you can use that thing for a bell if you decide you want to. Water pump failures, I've seen the impeller come off of them. Bearing seal, it's going to have a weep hole. You know, there's your weep hole right there where it weeped out of that one, and sometimes you'll see it running down the radiator hose coming from the water pump area. It's not that hard usually to get under there and see that weep hole on the ones that don't have the water pump driven by the timing chain or something like that. Of course, a lot of times if the water pump is driven by the timing belt, you may not be able to see the weep hole without pulling the cover off and looking at it that way. And so I've mentioned this before, but on the ones where the impeller is facing the reaction surface is built onto the water pump instead of into the timing cover, if there's I had that one time that the impeller wasn't pressed on there all the way, and instead of having like 20 thousandths of an inch clearance, it had like 70 thousandths of an inch clearance, and the car wasn't running hot, but it was running hotter than it was before I changed the water pump. And the old man that owned that Plymouth Volare said he wasn't going to have that, and so when I pulled the new water pump back off that I had ordered, and then I got a second water pump, I could immediately see a difference in the clearance between the impeller and the reaction surface. If the reaction surface gets cavitated, like on an aluminum pump, so that there's too much, or if the impeller rusts away, you're going to wind up having, you know, I've seen a Taurus one time that the only complaint that the girl had was the heater didn't work. And we hooked clear hoses up between the 2 heater hoses, and there was no coolant circulating in there. Pulled the water pump off, and the impeller was rusted away. And so we put a water pump on that one and fixed her heater. Why it wasn't overheating, I don't know. But this is weird stuff. I had one time that's later on we worked on that other one that I broke crankshaft, or it was one like it. And it would run 200 degrees sitting there idling in the service bay, but when you backed that thing out, started driving it away before you even went 100 yards, it was trying to overheat. pulled the water pump off. The impeller had come off of the water pump and was just laying there. Now, how that thing managed to run cool sitting there idling, and it was a 4.2 Ford, just boggled my mind. It seems like a theoretical impossibility. But heads are the hottest non-moving part. It's not a moving part where the valve moves, but the heads get really hot, and they'll have little holes in the gaskets where the water is supposed to slow down before it goes through the head, so it's got time to gather the heat. If you ever see gaskets that have holes, and I saw some Fel-Pro gaskets one time, they were accidentally cut with holes going into the coolant holes going into the heads that were the same size as the holes in the block in the head. My student caught that, comparing it to the old gaskets called Fel-Pro. They were terrified, says, please don't put those gaskets in there, you'll burn that engine up. So they sent us another pair of gaskets. Well, the coolant passages, the gaskets have a little tiny hole here, and they won't be near as big as what you see here. And it's to slow the coolant down to go through the head's coolant. This is a cracked head off a Chevy. You can see water coolant had been getting from here and here, because look how rusty that valve is. See that? None of the other valves look like that. This one actually, we pulled a spark plug out and saw some rust on the spark plug, but that's a 3-valve Ford head, so on and so forth. Gaskets and seals, these multi-layer gaskets are really good. But they always are working on gaskets. Gaskets are not just a piece of paper between two pieces of metal. There's a lot more to gaskets than you think. If you've got something like an EGR valve, it's iron that's bolted to an aluminum intake, it'll have a gasket with graphite on it, because the different expansion and contraction rates of those metals mean they'll scrub the gasket off if it doesn't have something slippery. That's why they put graphite on it. Head gaskets can fail in multiple ways. This was one where coolant was working its way from here and here, and it didn't have any combustion leaking into the coolant, but it had coolant making its way in here under pressure, and whenever they would park it, it would start and leave it sit. They'd come back out and crank it up, it'd be skipping on one cylinder until it cleared up, and it did this every time they parked it hot. And because it would weep coolant in there, you can see this crusty stuff on here is actually coolant deposits. If you pull plugs out, if you crank it up while it's skipping on a situation like this, switch it off, pull the plugs out, one of them's got steam coming off of it, that's got a head gasket that's letting water get in there. Now it won't overheat, but see, a lot of people will say blown head gasket, just whatever, but it can blow between cylinders, and that's making it have low compression between cylinders. It can blow so that it gets combustion into the coolant, and that's going to make it overheat. You put a glove, pop one of your gloves over with a rubber band over the radiator neck or a balloon or something, and you can actually crank the thing up. And if that glove starts to inflate within about a minute of cranking it cold, you got coolant getting into that system. On some of at the filling station, I learned that if you crank one up and let it run about 60 seconds and switch it off and pull the radiator cap off, it goes, you got head gasket issues. All right, find out which cylinder. What's this?
Okay, what we did here, checking for a blown head gasket on this 2001 Sebring. We got the spark plugs out, all of them except one. Then we spin the engine and we see if the water jacket produces bubbles. And if the water jacket produces bubbles when we're spinning it, we got it all the way full up. We pull the thermostat out, which is right under that cap, so we can see if we're getting bubbles. When we spin it over, the compression that's in that number 3 cylinder is making its way into the water, and it's causing those bubbles. You can also see that it's kind of disturbing the water as it spins over. And that is the number 3 cylinder.
If you spin one over, full, cold engine, and you see bubbles coming up, then you got, into the, fill the radiator or whatever all the way up. If you see bubbles coming up there, then you got some compression working its way into the water. Now make it overheat. You can actually pull the plugs out one at a time, spinning it over like I was showing you there, and figure out which cylinder it is that has the leak. Overhead cams have got that high pressure oil. I've shown this picture several times, but this is on the Dodge 98 Dodge Stratus. Any of them, Volkswagen Rabbits have this right in the center of the gasket. And this one here was leaking really bad. They said it needed a rear main seal at a shop down in Florida, and he said they don't believe that. So he came up there, and we put a dye in there, found this, put a head gasket on there, and took care of their oil leak, which it was dripping off the bell housing, and that's, you know, people without even looking to see where the oil was coming from just assumed it was the rear main seal. Puff of smoke at the first start, you're going to push the valve seals on, or if it's smoking at idle. And if you see deposits like this, that's going to be valve stem seals. And that'll also cause a surge too that will go away when you unplug the EGR valve, believe it or not. Because you'll be think that you got a problem with EGR when you've actually got other issues. Some valve stem seal jobs are harder than others. This is a 2.2 Camry. The shop, the dealership pulled the head off into the machine shop. What we figured out, I built this tool using that piece of metal, an old C-clamp, and this red part I got off the tool truck. And we actually replaced the valve stem seals on 2 or 3 of these Camrys by just, you know, one at a time, working their way through there. And we put air in the cylinder to keep the valve from falling out of there. This is a little easier on the older V8, you know, but you're supposed to put air in the cylinders so that whenever you would try to open the valve, some of the diesel guys would run the piston all the way up so the valve couldn't come, you know, drop in there. But you have to remove the timing chain and camshafts and all that kind of stuff. It's a big job. But pulling the head and putting it back on, 17 hours labor on one of these Camrys like this, that's a $2,000 repair. You kind of got to know what you're doing to do this, but like I say, we basically managed to make this happen. Oil leaks can be from the splash area, the sump area, or the oil pan timing cover, or they can be from a pressurized area like an external oil pump, head gasket passage I was talking about, the rear main seal, whatever. And I don't know how many times I've seen oil pressure sending units will fail and start to leak oil, and that was on a 3-liter Ford right there. All right. Intake, compression, power, and exhaust, all 4 cycles got to be working right. Tight combustion chamber, do your cylinder leakage test and your compression test. Good fuel supply and quality, good spark and spark timing, all that's got to come together. It's a holistic thing. Unrestricted flow of clean air is needed into the intake and out the exhaust. You know, out the exhaust is, wouldn't be clean air as much as going into the intake, but the point is, it's got to be able to breathe. And if anything keeps it from breathing, it's not going to do right. You're more likely to have a breathing problem here than you are here, except in one case where this guy drove his Mustang into a mud pit and got a bunch of mud in the air filter and clogged it up completely where it wouldn't start. But I think that air filter weighed 10 pounds. The car was clean. You couldn't tell he'd been in the mud. A free breathing exhaust system will have less than 2 pounds of back pressure. We are done for the day. We've been here 37 minutes. I hope you had time to last till the end, and I hope you got something good out of this. And I'll talk to you guys next time. Thanks for coming by. Share the video. Let me know what you think about it. Talk to you later.